In Module 1, the first thing that we're going to take a look at are percents and proportions. So just to review, there's a couple different ways that you can find percentages, but I'm going to use the method that ends up setting up a proportion just to keep things consistent. So when you're solving for a percent, we're going to use the equation x over y equals p over 100. Now in this case, x is the value, y is the total, and then p is the percent. Now you have to be given 2 out of the 3. So you can be given the value and the total and solve for the percent. You can be given the total and the percent and solve for the value, or you can be given the value and the percent and solve for the total. So what we do next is we cross multiply and set the products equal to each other. Then we finally solve for our variable. So to take a couple ways we can apply this, our first example says what percent of 32 is 4? So 4 is going to be our x, it's our value, 32 is our total, and so that means we're solving for p, our percent. So we're going to set up the fraction 4 over 32 equals p over 100. So we're going to cross multiply. We get 32p equals 400. We'll divide by 32. And we'll get 12.5. Now because the question is asking me for a percent, I am going to write my final answer as 12.5%. Our second example asks us 41% of 78 is what number? So 41 is obviously our p, 78 is going to be our y, it's our total. So we're trying to find the value that's 41% of 78. So we're going to set it up as x over 78 equals 41 over 100. So when we cross multiply, we're going to get 100x equals, and 78 times 41 is 3,198. We're going to divide by 100, and we're going to get x equals 31.98. Now I don't have to write any units on this problem because I didn't solve for a percent, and since I don't have a context, I don't have like units. Now I can have a decimal here, because again, it's not a word problem. If I were looking at a word problem, I'm trying to figure out 41% of 78 students is how many, then obviously I would need to round up to a whole number because we're talking about people. So it is going to depend on the context whether or not a decimal is going to make sense. So the second thing we're going to look at is proportions. So proportions are most widely used in word problems. So when you're setting up an equation for proportions, you have to have matching units in the numerator. So whatever values you put in the numerators of your fractions on either side of the opposite sign have to be the same, and you have to have matching units in the denominator. Now obviously one of these locations is going to be our variable. So that's going to be the one that's missing, that doesn't have a matching. And then our next two steps are the same as percentages. We're going to cross multiply and set the products equal to each other. And then we're going to solve for our variable. Like I said, the most common way we're going to see proportions is in word problems, but that's not the only place. We can have just regular equations, like our first example, 2 over x equals 7 over 14. So if I want to solve for x, I'm going to cross multiply. We'll get 7x equals 28, divide by 7, and we get that x equals 4. Our more common example is something like number 2. So you drive 25 miles in 2 days, and we want to know how long will it take to drive 137.5 miles, assuming you are consistent across the days. So we know that I can go 25 miles in 2 days. So that's my first fraction. So the other fraction I set up on the other side of my equal sign, I have to have miles in the numerator and days in the denominator. So I have 137.5 miles, so it's going to go in the numerator. I don't know how many days that's going to take, so that's going to be our variable x. We cross multiply, we get 25x equals 275, divide by 25, and we get that x equals 11. Now because this is a word problem, I do need to have units on my final answer. So x in this case, we were solving for days. So the answer is 11 days. Let me know if you have any questions over percentages or proportions.